Hey everybody, welcome. This is Mr. Gannon, and in this video we're going to take a look at the 4.1 notes for Algebra 2, where we're going to focus on graphing quadratics that are in vertex form. So the first thing we're going to do is take a look at what the graph of a basic quadratic function looks like, and that's from the parent function y equals x squared. Typically what we're going to do when we don't know what the shape of a graph looks like is we're going to make a table and find some coordinates. So we can pick the x values that we want to choose. I'm going to go ahead and start with -2, -1, 0, 1, and 2. And those are the x values we're going to plug in to find our y values. Now, I choose these because you've got a couple negatives, a couple positives, and 0. So that should give us a pretty good idea of what's happening on this graph. The equation says y equals x squared. What that tells us is that y is going to equal whatever x is squared. So if I take -2 and I square it, I'm going to get a y value of 4. If we take -1 and square it, we get a y value of 1. If we take 0 and square it, we get a y value of 0. 1 squared is 1, and 2 squared is 4. So we're using the equation to tell us what the relationship is between x and y. From there, when we have the x and y coordinate that go together, we can form what's called an ordered pair, which is x comma y. So this is the coordinate -2, 4. This is -1, 1, 0, 0, 1, 1, and 2, 4. Once we have those points, we can go over here and plot them on the graph. So I'm going to go ahead and start just the top one. So -2, 4 means from 0, 0, we're going to go left 2 and up 4. -1, 1 means left 1, up 1. 0, 0 is the origin. 1, 1 means right 1, up 1. And 2, 4 is right 2, up 4. So those are the points that are on our graph. And we could pick different x values and find more points. But from these 5, we should get a pretty good start to get a picture of what the graph looks like. Now these points, I can't draw a straight line through them. And what ends up happening is you have to draw this curve that looks sort of like a U. And the name for it mathematically is it's called a parabola. So the graph of a quadratic function is going to be a parabola. And some of the key elements of this parabola that you want to make sure you understand are, it has a vertex at 0, 0. So the vertex is the point 0, 0. Now another thing that's important is how do we get from this vertex to the other points? Well, we're going to go right 1, up 1, and left 1, up 1. But at the same time, if we go right 2 from that point, we go up 4. If we go left 2, we go up 4. And the reason for that is left or right has to do with our x value. Up and down has to do with the y value. Y is x squared. So whatever x is, we square that, and that's how far we go up. So over 2, I'm going to go up 2 squared, which is 4. So that pattern is important for us to recognize when we're graphing these parabolas. One of the other important characteristics that you're going to be asked about is the axis of symmetry. The axis of symmetry is an imaginary vertical line that divides the parabola into 2 equal halves. So in this case, that's going to be this line. That doesn't really show up. It's going to be this vertical line that goes right through our vertex. So in this case, the axis of symmetry is always going to be found using the equation x equals h. And the h is coming from the fact that the vertex is h comma k. All All right, we'll talk about some other things as we go through here. But for now, let's go ahead and take a look at some of these graphs. So just like we could take lines and write them in HK form, we're going to be able to do the same thing with parabolas. So y equals a times x minus h quantity squared plus k. It's this exponent of 2 that tells us the graph has to be a parabola. Everything else in terms of transformations will be exactly the same as it was in chapter 1. All right. So if we go ahead and take a look at example 1 here, the first thing we're going to do is identify the transformations. So the plus 2 inside the parentheses is going to move the graph left 2. The minus 5 is going to move the graph down 5. And those are the only transformations that this graph is going to have. So from there, because we know it's going to be a parabola, let's go ahead and graph it. From 0, 0, we're going to go left 2, down 5. There's the vertex. Because there's no stretch or compression, this graph is going to follow that same pattern that this graph over here did. Right 1 up 1, right 2 up 4. All right, so let's go ahead and do that. Right 1 up 1, right 2 from the vertex, up 1, 2, 3, 4. But the same thing happens if I go left 1, I go up 1. If I go left 2 from the vertex, I go up 4. Now, we didn't go over this in the other case, or in the other example, but if I were to go right 3, we have to go up 3 squared, which is 9. So it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9. And that would also be true if I went left 3, I'd go up 9. And you can see that the graph is a parabola. All right, there are some things we have to then go ahead and be able to identify. So the vertex is left 2, down 5. That's going to have coordinates -2, -5. That is coming directly from the transformations. The y-intercept, this is where the graph is going to cross the y-axis. In this case, it's right here. So we can use the graph to identify the y-intercept, and in this case, it is 0, -1. Now, there might be a situation where you're not able to identify the y-intercept from the graph, because it might cross the y-axis somewhere that doesn't appear on what you actually graph. So an alternative way to find the y-intercept is take the x-coordinate of 0, because every point on the y-axis is going to have an x-coordinate of 0, and plug that into the equation. So this would become y equals 0 plus 2 quantity squared minus 5. All I did is plugged in 0 for x. If you simplify this, 0 plus 2 is 2, 2 squared is 4, and then 4 minus 5 is -1. So that's another way you could find the y-intercept if you're not able to identify it from the graph. All right, next. The next question says, what is the max or minimum? These parabolas will always have one or the other. It will always happen at the vertex. So right here, this point, the vertex, is the lowest point on the graph. That means it is a minimum. It is the smallest y value. So the minimum of -5. Domain. Okay, domain looks at the graph from left to right. In this case, our graph is going to go left forever. It's going to go right forever. So our domain is all real numbers. The range is going to go bottom to top. So if we look down here at the bottom, the graph doesn't go down forever. The graph doesn't start until we get to this point, and then it goes up forever from there. So y is greater than or equal to -5 in that situation. The last thing that we're asked to do is identify that axis of symmetry. And what we talked about over here is it's always x equals h. And h is going to be the x coordinate of our vertex. So the axis of symmetry in this case is x equals -2. And what we're doing is we're identifying this vertical line that divides the parabola in half. All right, so that's how we can take the parent function and those transformations we've learned before and graph a parabola. Some of the things you guys hopefully are able to recognize as you look through here are that this value going down is what gave us the y coordinate of our vertex. That's also where the minimum value is coming from, and it's part of the range. The other thing that can be helpful to recognize is that the x coordinate of our vertex is always going to be the same as our axis of symmetry. And that's coming from that left and right transformation. So the more you understand how these go together, the easier it becomes to graph these. All right, what I would recommend is you guys pause the video, try to graph number 2 on your own. All right, now, hopefully you guys tried number 2. Let's take a look at what it should look like. So from here, again, we have that x squared. That's how we know our graph has to be that parabola shape. The negative in front is going to be a reflection. The -3 inside the parentheses is going to move the graph right 3. And the +6 is going to move it up 6. So we're going to start there and graph that vertex. So from 0, 0, we're moving right 3, up 6. That's going to be the vertex. What the reflection does is tells us that instead of the graph opening up, it's going to open down. So instead of right 1, up 1, I'm going to go right 1, down 1, left 1, down 1. All right, so when I say left 1, left 2, right 2, I'm always referring from the vertex. So now if I go right 2, I'm going to go down 4. If I go left 2, I'm going to go down 4. All right. Again, we are going to be asked to identify the y-intercept. So if I go left 3, I'll be on the y-axis. So left 3 is down 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's where that point should go. All right. So the graph looks like this. The vertex was right 3, up 6. So that's going to be 3, 6. The y-intercept is this point right here, which is 0, and we went down 1, 2, 3, 4, so -4 from the origin. All right, minimum, maximum. The vertex this time is the highest point, so it's a maximum of 6, because that's the highest height our graph reaches. Domain looks at the graph from left to right, so it goes left forever, right forever. That means that the domain, all real numbers. Our range looks at the graph from bottom to top. It's going down forever, but it stops at this point. Okay, it doesn't go up beyond here. So we're going to go ahead and say y is less than or equal to 6. The axis of symmetry is that imaginary vertical line that passes through the vertex, which in this case is x equals 3. All right, hopefully you guys were able to come up with that on your own. If not, hopefully it makes more sense right now. All right, let's go ahead and do a couple more examples, and that hopefully will be enough to get you guys started on your homework. So for number 3, we have x plus 2 in parentheses, so the only transformation is left 2. All right, so from 0, 0, we're going to go left 2, put our vertex. There's nothing else being done to the graph. So it's right 1, up 1, left 1, up 1. Go back to the vertex, right 2, up 4. 1, 2, 3, 4. Left 2, up 4. And then just draw the parabola passing through those points. Our vertex is -2, 0. Our y-intercept is this point right here, 0, 4. All right, the graph does not go down forever. Instead, it goes up from this point, the vertex. So we have a minimum of 0, okay, because the height is 0. The domain, left to right, is all real numbers. The range from bottom to top, y is greater than or equal to 0. All right, because if you start at the bottom, there's nothing until we hit that vertex point. Then it goes up forever from there. The axis of symmetry is that imaginary line passing through the vertex. In this case, x equals -2. All right, pause the video, give number 4 a shot. All right, so if you tried 4, the negative in front of this function is going to cause a reflection. And the +6 is going to move the graph up 6. And one thing you want to be careful with here is we know it goes up 6 instead of left 6 because there are no parentheses. So from there, I'm going to go ahead and start graphing it. So from 0, 0, I'm going to go up 6. 1, 2, 3, 4, 5, 6. It's a reflection, which means instead of over 1, up 1, it's over 1, down 1 in both directions. Over 2, down 4 in both directions. All right. And those are the only points you really have to actually plot. If you went over 3, it'd be down 9 in both directions. All right, as we start to answer the questions from the graph, our vertex is at 0, 6. Our y-intercept also happens to be that same point, so it's at 0, 6. This graph is opening down, so there's a maximum of 6. Domain looks at the graph from left to right. It's going left and right forever, all real numbers. All right, the range is looking at the graph from bottom to the top. This time it's going down forever, but it doesn't go past this vertex. So y has to be less than or equal to 6. And then the axis of symmetry is that vertical line passing through the vertex, x equals 0. So for this lesson, you really need to make sure you understand the graph of the parent function. You know, the vertex starts at 0, 0. If you go right 1, you go up 1. If you go left 1, you go up 1. Because of the symmetry, it's going to be the same on both sides. From that same vertex, if you go right 2, you go up 4. And if you go left 2, you go up 4. If you can take that and put it together with the transformations, then you're going to be successful at graphing these functions. I am going to do one more video here where we will take a look at some stretches and compressions and kind of summarize those transformations. So make sure you check out video number 2.